Today we're going to talk about ENS for Server. It's security designed specifically for virtual platforms. Let's look at the top 3 security pain points when it comes to securing the cloud. First of all, IT must have complete visibility into all workloads, no matter if these are running within the enterprise firewalls or off-premises, like within a cloud. Achieving the security visibility to all computing resources on-prem and off-prem is key to when it comes to securing the hybrid cloud. The second challenge is detecting breaches including advanced targeted attacks. IT can no longer focus on protection only, but must assume hackers do get through. Therefore, IT must put into place strong detection capabilities. Due to the ever-evolving threat landscape, it is almost impossible for security staffing to keep up, and security administrators often lack the ability to sufficiently manage the threat landscape. IT needs a security solution that can address today's emerging threat challenge to find threats sooner and stop them faster. Furthermore, detection efforts must be able to traverse a heterogeneous compute environment without significant delay in the detection and remediation timeframe. This challenge has risen to the top of the list over the past few years and has generated boardroom conversations due to the level of risk. In addition to lack of visibility and detection capabilities, you're likely to be familiar with the third challenge. How can IT solve the overall complexity and efficiency issue? IT needs an integrated approach across the threat defense lifecycle to centrally define security policies, monitor security status, and respond to threats, as well as manage security in an elastic fashion as compute resources are spun up and down. So, virtual servers, technology options. McAfee has 2 different options. Move, which is McAfee optimized for virtual environments, and ENS for servers and VDI. Move comes in a couple different what we call flavors. It's agentless, which offloads scanning for VMware, and then the Move multi-platform, which is optimized for virtual environments, supports multiple hypervisors, VMware, Xen, KVM, and it's anti-malware with integrated management and threat intelligence. ENS, on the other hand, is next-generation technology optimized for virtual servers and VDI. It's optimized for hypervisor performance while leveraging all benefits of next-gen security solutions. And you can execute resource-intensive tasks such as on-demand scanning based on hypervisor load. So here are some use cases around the different technologies. Move can help prevent scan storms. It's a benefit of what we call our global cache. So for example, at 9 a.m. all employees log into the VM causing the scan storm, and non-persistent VMs can be created from templates every day. Move prevents these performance impacts due to the DAT and on-demand scan storms. You'll need a second layer of security. The primary is the perimeter, and then you have a separate security for your data stores as well. It also has a smaller footprint. Again, this is specifically for VDI to reduce the resource intensity that is put on these virtual environments. It's a small footprint. It's an ageless scanning capability in the background. You can squeeze more VMs into that density, and like I said before, it's only signature-based scanning. ENS, on the other hand, is zero-day protection. It's the next-generation capability providing behavioral protection via our Real Protect machine learning and DAC, which is our dynamic application containment solution. It also provides IPS protection, access protection, and exploit prevention. We prevent performance impact due to DAT and ODS storms by executing resource-intensive tasks when the hypervisor is not loaded, and we'll talk about how we determine that later. Endpoint security is the primary security on your system. You don't need a second layer of security, as ENS provides not only the ENS functionality for threat prevention, we have firewall, web control, DLP, encryption, etc., all within this endpoint security capability. We provide ease of management, so it's the same security across physical and the virtual infrastructure, all managed by EPO, and we support ENS for Linux as well, same management capability. Limitations: it doesn't prevent the scan storm, but like we said earlier, we have scheduling capabilities that provide us to do our resource-intensive tasks when the hypervisor is not loaded. So, ENS for servers. Why is it beneficial? Well, you use ENS along with adaptive threat protection on both servers and VDI, so you get our next-generation capabilities, not only on servers, but VDI, and across physical infrastructure. You can execute those resource-intensive tasks, such as on-demand scans, or DAT updates only when that hypervisor load is below a specific limit, so you can specifically set those limits for your environment. You can have better VM density than ENS due to lower hypervisor CPU utilization. You can schedule tasks such as on-demand scans to run during off-peak times, support for both Windows and Linux, and no change in ENS experience. So this feature is delivered using the McAfee agent 5.5 and above, and connectors for cloud workload security, and we'll look at that as we progress down this demonstration. Here's what cloud workload security looks at. We will do a live demo in a few minutes, but you're able to do what's called register the VM where it counts. You also have the capability of registration of public clouds, AWS, Azure, etc. CWS will discover the virtual systems running on that hypervisor without agents using the VMware API. CWS will check that hypervisor load every 5 minutes, and new systems will be discovered every 5 minutes and brought into the cloud workload security functionality. You're also able to select the smart tasks and schedule them. This provides you the capability of running on-demand scans and other custom tasks only when the hypervisor load is low. Your smart scheduler is what allows you to run them off-peak. So when the load on the hypervisor is below a specific limit, the McAfee agent on the host will execute the task only when the hypervisor tells us it's below a specific limit. You can specify also off-peak times as to when we want to run our tasks. This is an example of running Smart Scan versus without Smart Scan. You'll notice on-demand scans run in batches, utilizing the capability of determining the hypervisor load and only adding new systems when that load is below a specific threshold, versus without Smart Scan, which will peg your CPU to 100% or above during these scans. Here's a great chart that compares Move to ENS for servers. In this chart, we go through different features and where it fits into your infrastructure. The nice thing is you can choose your solution based on your requirements and pick the best solution for your environment. Let's get into the demo. Now we're looking at our demonstration. We're looking at the EPO console. This is a reporting dashboard for our public cloud. Since we've checked in our CWS and ENS for servers capability, it's automatically added these types of dashboards in for our viewing. Things such as data center distribution, OS distribution, any security events we've had, status of different products that are installed, and even usage metering reporting for our AWS, Azure, and public cloud capabilities for our environment. What we're going to do first is we're going to show how we check in the extensions for our CWS and ENS for servers. Let's go to Menu, then Extensions, and we would click Install Extension. You'll notice we have a couple different types of connectors in this environment, depending or not whether you're checking in the capabilities for your private, public, or hybrid clouds. Different extensions will be checked in. Next, let's show the client products. So we click on the menu, Software, Master Repository. Now the nice thing about cloud workload security is we get the capability, but you don't need to deploy any additional products to your hosts. So it will just be the McAfee agent and then the ENS platform. What is required is the McAfee agent 5.5. You'll see it's checked in here. And then you also need the ENS platform, which we see all of them checked in here. We have 10.5 patch 3 in this environment. Next, let's talk about the Smart Scheduler. Remember, the Smart Scheduler runs resource-intensive client tasks based on the priority and availability of resources on the hypervisor. So, we'll click on Menu, Configuration, Smart Scheduler. When resource-intensive tasks run on all the virtual machines at the same time, the hypervisor CPUs can be overloaded, and this can cause the hypervisor to crash and all of its virtual machines become unresponsive. We don't want this to happen, so when this feature is configured, resource-intensive tasks are scheduled so that the CPU utilization on the hypervisor does not significantly exceed the specified threshold. This is how we set this up. We can specify a time. Basically, you click to select or deselect a time slot, and then you specify the CPU threshold value for the hypervisor. Making a note that it's very important to set your scheduling long enough for your tasks to run. So how does smart scheduling actually work? So what we do is we create smart scheduler tasks. We can do this by clicking on Menu, Policy, and the Smart Scheduler Catalog. And we add them to the Smart Scheduling interface. The Smart Scheduler sends the information about these different tasks to the agent on the hosts. Now, the Smart Scheduler allows you to configure the Smart Scheduler time slot, like we just looked at, on a day-to-day basis. But then we have the client service, and this gets the request from the Smart Scheduler to execute the smart scheduling tasks and never run them above a specific hypervisor threshold. So how is that hypervisor load calculated? So quick note on this, when the CPU utilization of the hypervisor is calculated before triggering any resource-intensive tasks, the tasks can be scheduled based on that load, so that the CPU utilization of the hypervisor does not significantly exceed the specified threshold limit. So during the allocated time, Smart Scheduler gets the CPU utilization value of that hypervisor every minute from the Cloud Workload Security solution. We'll look at that in just a minute, how we set up the connecting. But based on the difference in the configured threshold value and the current CPU utilization on the hypervisor, Smart Scheduler decides the number of systems that can run those resource-intensive tasks within the configured threshold. If you remember, during our PowerPoint, I showed the threshold limits, and it actually spins up systems in batches versus spinning them up all at the same time. This keeps the workload below that scheduled threshold. Now, let's go look at the Cloud Workload Security. So we looked at the Smart Scheduler, we looked at what we need to check in, and we looked at the catalog. You're basically able to just add tasks to this. What is Cloud Workload Security, and what does it do for us? What's the role? So Cloud Workload Security sends critical information to the Smart Scheduler at every sync of the registered cloud account, which enables Smart Scheduler to make these intelligent decisions of what to spin up and what to spin down. So what type of information does Cloud Workload Security send to the Smart Scheduler? Shows the list of VMs that are available in the registered cloud accounts, updates on additions or removal of VMs, the load of the hypervisor in percentage, right, maximum load that was reported in the last minute, and then power status of the VM's Cloud Workload Security, which calculates the CPU utilization of the hypervisor every minute and keeps the values in that database. The Cloud Workload Security panels provide information about total workloads we have in our environment, compliance events, threat events, and then any types of pods or other high compliance events we need to look at. The compliance events displays the compliance summary of all the powered on instances. Compliance is basically set by policy. It goes and looks for specific things to report compliance on. Next, threat events is basically a display of all the threat events of powered on and powered off instances. So you can see the threats in your environment irrespective of the machine status. You can view total workloads, compliance, workload discovery, etc. They also color code the events, so anything in red is high, anything is medium is a warning or moderate. First thing we want to do though while we're here is show how we can check in and add a cloud account. When we start talking about different cloud accounts, as you can see here in our Cloud Workload Security, we show some Azure and AWS, but if you scroll down, we also show virtual VMware instances as well. So when we click Add Accounts, there's different types of accounts we can add. Here are the current ones checked in. We just select the Add button. In here, it asks us what type of cloud account we would like to register, anything from AWS to Azure, OpenStack, and VMware vCenter. We even have the Kubernetes cluster capability as well, which has to do with different clustering functionality for AWS services. We want to say it's a VMware vCenter for our private cloud. Here's where we add the account name, server address, a username on the account, a password, and then the assessment policy. Remember, this is set through policy capabilities. My default just checks for specific items, whether or not they're on there, and then you can tag different items as well. So what EPO tags are we looking for? What's the port we look over, and how often do we go and look for it? Last but not least, we can add some Windows domain credentials as well. If we had those, we would test the connection, click Next, and add our cloud account. It's really that simple. What will then happen, and we're not going to do this in the live demo because we already have them checked in, but we'll go out and actually query our hypervisors for all of the systems that we have running in our environment. So that's how you check in a cloud account. Next, we're going to see how we can take action on a managed system. We have a number of cloud accounts registered, but we're going to focus specifically on our VMware infrastructure. So we have a bunch of systems running in our Reston lab, and right here it's showing issues within our workloads, products, tags, and the actual workloads themselves, and how many events are associated with those workloads. So we're going to break this down specifically by the workstation tag. This is a tag that gets set on systems that are basically Windows workstation systems when they become managed. So we see a tag here called workstations. I'm going to click on this, and you notice I have one workload in there. So it's this one system. There's been 5 events. These five events are specifically around protection that's been deployed. So you'll notice that threat prevention has no issues, but we have a number of things that are not installed. So how do we deploy it directly from here? And this is where it actually gets really cool. So we're able to select the event, and then once we select the event, it brings up more information about that host. It shows me that it's managed. I'm running the 5.5 agent, and then it shows me information about the solution. So threat prevention is enabled. It has all of that installed. It's got the latest DAT update, but I don't have my adaptive threat protection, and I'd like to install that. So how do I go about doing that? Quickly though, it shows me my system properties, and here's that workstation tag that gets specifically deployed to Windows workstations. I'm able to take action on the assessment policy, but I'm more specific on how I want to deploy capabilities, right? So the nice thing is I have a take action item right here where I'm able to install different functions specifically around this action. So remember, what I wanted to do was I want to install the adaptive threat protection. So I can click on install adaptive threat protection and then go ahead and install. Now what it's going to do is it's going to push this task out to the host and deploy adaptive threat protection. Now we've moved over to our host, and you'll notice that it's received a task directly from the EPO server. There's our host name, Win10x64CK03, and you'll notice that it received a task to install the Windows ATP through the Cloud Workload Security capability. So without any further ado from us, we said go ahead and deploy that. It's downloading the package, and it's installing our adaptive threat protection. Next, we're back in our Cloud Workload Security console. The next thing we want to look at is, what if we have an unmanaged host? Are we able to deploy agents and manage those hosts directly from CWS? Yes. So how do we do that? Well, we want to look in our environment, and what we're going to do is we're able to basically look at the different workloads and the different events that are in these workloads, and then deploy capabilities to these different things. So, we can scan through, pick whatever. This is an environment that we have is just a demo environment, so obviously it doesn't show a lot of managed hosts, but it's great for us to kind of pick one and send an agent to that. Now we're back in our Cloud Workload Security console. And what if we have an unmanaged host? Are we able to take action on that and manage that host? Well, the answer is yes, we can. So you'll notice we're looking at our virtual infrastructure and REST-in, and we're just going to pick one of these workloads right here. This is a demo environment, so there's a lot of things for us to pick from that are unmanaged, but we have something called W7 WH01. You'll notice everything's not installed. So we have no threat prevention, we have nothing installed. So we're able to take action directly from here. We're going to select this event, and you'll notice a lot of information pops up in the workload details for this host. It is unmanaged, but the interesting thing is we're still able to pull information about it, such as system properties, instance name, operating system, and then also DNS name and IP address. We can take action on the assessment policy if we want to add that in, so it can determine different events and policy items that it's looking for, or we can take action directly from here. And the nice thing is just like in that other host, we're able to install an agent or install other types of capabilities. So we're even able to quarantine the workload, put it in maybe in a different VLAN, and show other information. You can tag it, put it in a different group, etc. So what we're going to do is we're going to install the McAfee agent so we can then manage this host. It's literally this easy. We can then select OK, and now we've just deployed the McAfee agent out to this host. So hopefully this demonstration was helpful to show how Cloud Workload Security can help you manage your cloud environment, whether public, private, or hybrid cloud, from an easy one console capability, taking action directly from here.